So, hello student. So, we are at module 11 disposal of solid waste. Now, today we will talk about leachate collection and treatment. So, as I explained in the previous lecture, there are two main environmental issues from landfill area. One is leachate production and polluted gas production. So, normally this landfill also designed by the geo-environmental engineering academicians or researcher, because there the lining things has to be designed properly, that liner things, soil quality. But for as an environmental engineering, we have two major issues. One is the leachate problem and second is the polluted gas problem. How best we will be able to collect leachate or gas and treat. That is our task for the environmental engineers. So, today we will talk about leachate part. So, the first that there are, as I was explaining about, there are two major common problem with the landfill. First is the leachate. That leachate is a liquid that forms when the landfill waste breaks down through biodegradation process and rainwater enters in the waste. Here the major concentration of that rainwater, because it is open to the atmosphere. So, huge amount of rainwater is entering into the landfill area, and I think that breakdown to the entire material, so which will collect the all contaminants and that will go to the groundwater, will pollute that. So, this is what the landfill leachate. So, rainwater is the greatest contributor of the leachate. So, chemicals commonly found in the leachate includes methane, carbon dioxide, organic acid, alcohol, aldehydes, apart from BOD5, organic matter, metals. Now, next is the landfill gases. So, because of degradation of biodegradable matter, I think this is all groundwater, again the different pollutants and the gases, major is the methane and carbon dioxide. So, organic materials such as wet waste, especially vegetable, kitchen waste, are usually compacted when they are put into the landfill. The problem is that this removes oxygen and causes the material breakdown anaerobically. Over time, the process will produce methane, a type of greenhouse gas, which is 28 times more potent than carbon dioxide. So, it is a greenhouse gas. Methane, see, in the previous module we talked that methane is very useful gas. Once you will be able to collect that and to produce, can be used for the cooking purpose and can be able to produce electricity out of that. But in this case now, the methane we are not able to collect separately and the quantity is also not that large, which can be utilized for the further utilization. Now, what are the reactions occurring in the landfill area? The major is a anaerobic one only. So, the hydrolysis could be possible and fermentation could be possible, and finally, after that acid phase the methane will get produced, but quantity is not that large, and almost you see that the pH in that particular entire waste material will be always in the acidic condition. So, the concentration of methane also will not be that high. Now, what are the typical phases of landfill gas and leachate? So, there are 5 phases if you consider gas or leachate production. The phase 1, phase 2, phase 3, phase 4 and phase 5. So, like in the phase 1, the major gas production also, the different gas production. So, in this lecture we will talk about majorly the leachate one. So, you see here the graph of COD that is major into the phase 3. So, now the phase 1 is a acclimatization, the bacteria will get acclimatized and still that will be in the aerobic condition. Even phase 2 also will have some aerobic conditions, but mostly the entire condition will be converted in the anaerobic one, and the fastest degradation of that biological waste into the landfill area will be in the phase 3. So, that is normally called as an acid phase, where the maximum degradation could be possible. So, in the same case the gas production also will be possible and the maximum COD will produce. Similarly, in the phase 4 and even phase 5 the COD concentration will be very low. What are the factors influencing the leachate generation? The leachate varies widely depending on age of the landfill, type of waste and environmental conditions. So, the age of the landfill, obviously the leachate production will not be that large in the initial period like 2 year, 3 year, 4 year. Even the pollution load also will be not that high in the initial days, but after 4 year, 5 year the more amount of leachate also will get produced, because until that all the voids will get filled up and entire waste also is getting compacted properly. Both kind of manual compaction, even the natural compaction also could be possible to a particular year, and later on your leachate, the very strong leachate will get produced. And again depend the type of waste. So, this was already I discussed in the previous lecture. If you have the non-biodegradable matter, non-recyclable matter and only the inert material, some reject from the treatment process are reaching to the disposal site. So, obviously, you need not to worry about the leachate production. The leachate will get produced, but it will not be that polluted one. You need not to worry much about the leachate part, but now the mixed kind of waste is reaching, and in that case also like India kind of country where 60% or 50 to 60% is a biological waste, or some other countries where the biological waste goes to 60%, 80%. In that case, if the entire waste goes to the disposal site or landfill area, obviously you have to much worry about the leachate. Not only the leachate, but even polluted gas production also is a more concerned issues in the landfill area. And local environmental condition also is very important. Suppose nearby habitations, nearby some water storage area, or is a flood plains. I think these are some important issues will be more concerned for leachate production. And what are the factors which influences the generation of leachate? Is a infiltration of groundwater, infiltration of leachate in the ground as potential pollution of groundwater table, rainfall, water from the deposited waste mainly due to biodegradation process. So, I think we can see that the major concentrations are of leachate production is, one is the rainfall and second is the water mainly produced from biodegradation process. Now, if you take that there is no biodegradable matters are reaching into the disposal area. So, this quantity these factors is not important in that case, and now the rainfall or precipitation that you can't do anything is again depend upon, that is why the local climatological conditions are important. And some areas or some localities, especially in the northeast part of India, where rainfall goes to 6 months in a year or somewhere 8 months in a year. So, this is most important influencing factor for leachate production could be there. So, you need to look upon more daily cover issues in the landfill area. Even the final cover should be very strong enough, so that these precipitation should not reach into the disposal area. And there also in such areas, suppose if you are disposing the biological waste into the disposal site, then obviously you have to more worry about groundwater pollution or some surface water pollution in that particular area. Already I think such kind of things you can easily see in the northeast India, where the proper sanitary landfill has not been designed and mostly the waste is getting disposed in most of the cities in the northeast, whether it is Assam or other state like Tripura, Manipur. There is mostly cities are disposing the waste into the low lying areas, and because the rainfall is more than 6 months means your water table is also very high. So, the almost you can see that waste will be in the flooding conditions in most of the season of the year in that particular location. And also need to be checked that infiltration of groundwater, this is the important one. So, I think wherever the location you are finalizing, try to find such location where the permeability of soil is very poor, so that suppose that some leakage also in the landfill could possible, but if there is no permeability in the soil, so the leachate won't reach to the aquifer area, or that won't enter into the groundwater. Now, the schematic scheme of how the leachate is generated. So, I think this is a simple one. So, this is a precipitation, and because precipitation, so infiltration will be there, and also parallelly some kind of evaporations also will be there, and also the moisture content will be available in the waste material. So, because of that the leachate is getting generated. And is not that the entire the rainwater is getting infiltrated, because of that some runoff also will come up. So, this runoff also is adding into the somewhere in the local surface water locations or in the pond or some other reservoirs in nearby, that will get polluted because of that. So, factor that influence leachate quality. First is the refuse composition. So, quality variation in is higher for the putrescible waste than for non-putrescible waste. Putrescible means biodegradable waste. So, obviously, for biodegradable waste the quality will be something else, that variations will be more as compared to the non-biodegradable material. Elapsed time. So, leachate quality varies with time. In general, overall quantity of leachate generated in 1 year will be less strong than subsequent year. So, obviously, in the initial period the leachate quality won't be strong, but later on the leachate quality will be very strong for subsequent year. The ambient temperature affects the both bacterial growth and chemical reactions. So, this is also very important, like some of the location where temperature goes to 40 degree for longer period. So, obviously, your microbial activity will be very strong, and the degradation will be very fast. So, available moisture, the water plays a significant role in the biodegradation and subsequent leaching of chemical out of the waste. So, the available moisture also, this will come up because of biodegradable waste coming to the landfill area. So, more biodegradable waste, more moisture. So, more moisture means there will be a more leakage or more production of leachate. I suppose there is a low moisture like 15-20% moisture in the waste. So, first the leachate will get absorbed into the waste material itself, it will not come out so easily. Precipitation, obviously the amount of rain falling on landfill influence the leachate quantity also, and even the quality also. So, because the rainwater do not have much pollutants, so whatever the leachate is generating because of biodegradation process, and if that rainwater is mixing into that, so your quality won't be that strong. Quantity will be large, but the quality will be not that strong. Groundwater intrusion, sometimes landfill based construction below the groundwater table may increase the quantity. So, this is also one factor, the groundwater intrusion could be possible into, I think it is depend upon the, if the groundwater is very close to the earth surface or wherever I think you excavated the soil, then this intrusion could be possible. You can find this kind of intrusion very easily in northeast part of India. And moisture content of the waste. So, leachate quantity will increase because of bone sulphate, and waste releases pore water when squeezed. So, this is also that moisture available in the waste material. Now, the estimation of leachate quantity. So, the pre-closure, post-closure leachate generation rate in the landfill varies significantly and methods to calculate are also different. So, the estimation of pre-closure leachate generation rate is needed to determine the following: spacing of leachate collection pipe at the base of the landfill, size of the leachate collection tank, design on-site or off-site treatment facility. And in estimation of post-closure leachate generation rate is needed to determine the long-term care cost. So, normally for pre-closure generation rate, you can calculate by simple equation, that is pre-closure leachate volume we can calculate by sum of volume of precipitation and volume of pore squeezed liquid, that is excess moisture. You can reduce that from the volume loss through the evaporation and volume loss through the absorption in waste material. So, that is why to know that this volume of pore squeeze liquid, you need to know the moisture of the waste material, and because of that you will also come to know that how much volume loss through the absorption into the waste material has to be checked time to time, and by that way we can calculate the how much leachate generation rate could be possible. So, in the post closure generation rate, after the construction of final cover, I think is closed entire, only the rainwater that can infiltrate into the waste and generate leachate. So, the 5 approaches are available to predict the long term leachate generation rate. Is a water balance method. There are 5 methods, by that way we can calculate that. First is the water balance method, computer modeling in conjunction with the water balance method, empirical equation, mathematical modeling, direct infiltration measurement. But I think in these approaches, I think water balance is very easy, which I am going to explain it here. Is a simply we can calculate by post closure leachate volume from reduction from volume of precipitation of volume loss through the evapotranspiration, volume of surface runoff and volume of soil and waste moisture storage. If you know that these things, we can easily calculate how much leachate could be possible to produce. So, the water balance method is applicable only for the landfills like high permeable layer of soil is used in the final cover and low permeable layer of soil. So, I think these water balance method, these are the two considerations, the low permeable layer of soil in the ground and the high permeable layer of soil that used in the final cover. So, that rainwater will enter into the waste material, and suppose the low permeable soil has been added onto the as an final cover. So, a very small quantity of rainwater will enter into the landfill area. Now, if you see the typical characterization leachate characteristics, so the pH will be, as I said, is a huge variation in the pH. So, initially start with the acidic pH and followed by alkaline pH. The even electrical conductivity will be very high because a lot of solid productions in the leachate, and BOD 5 can go up to 1,95,000 can is a maximum is possible, and again I think this BOD 5 or COD value is again depend upon the how much amount of biodegradable matter, that percentage. If it is large, obviously your BOD 5 and COD value will be more, and if there is no biodegradable matter, so obviously your BOD 5 and COD value will be very low in that case, and also that the metal concentrations will be very large in the leachate. So, this is one leachate flowing through a pipe in a sanitary landfill. Now, these are the metal, the other parameter which I was talking about, like ammonium nitrogen, sulphate, aluminum, zinc, lead, chromium, these all trace metals is getting generated or we can find in the leachate. Now, this is the major problem. This once these metals are reaching into the any surface water, or if it is reached into the groundwater, it is very difficult to treat, or that kind of water won't be possible for consumption purpose. Now, the leachate collection system will have main drain, side drain, perimeter drain, drain and protective layer, and leachate wells typically with pumps. These are combinations in the leachate collection systems. And now, what could be the problem of leachate problem? There is a clog up with silt and mud and growth of microorganism in the pipe, chemical reaction leading to precipitation of minerals, and pipe become weakened by chemical attack, could be corrode, that is also possible. So, these are the few issues will come up, because once you put the drain pipes into the landfill facilities. So, obviously, we have to see time to time. So, what is the role of landfill or leachate collection system components? The barrier layer, very low permeable synthetic or natural soil liner to restrict and control the rate of vertical downward flow of liquid. Drainage layer, a high permeable gravel drainage layer to laterally drain the liquid to the collection drain pipe at least 30 centimeter thick with a minimum permeability of 10 to power minus 3 centimeter per second. Slope, that particular pipe slope to encourage lateral migration with minimum 2% bottom, finer slope after long term settling, and French drain and tiles, that is also important, and filter layer, that will be granular or synthetic, used above the drainage layer to reduce the potential for migration of fines into the drainage layer. Final soil or refuse, the permeability should be less than 10 to power minus 4 centimeter per second. So, leachate collection system, you can see here, this is the entire excavation. Okay. Now, this is the pipes, sorted leachate collection pipes. This is the perforated. Normally, you will see here the perforations will be like this. Suppose this is a pipe, so the perforation will be of this size, like in the top area. So, likewise, the perforations will be there, so that leachate will enter into the pipes. And finally, I think all these lateral pipes is attached with leachate collection line. Okay. So, you can see here this is those pipes, that is slotted pipe connection, leachate collection pipes. So, you can see here these are the collection pipes. Now, I have one the small 2 minutes video, you can by that way also you can see the how these pipes are laying down. So, you can see here the landfill area. This is the particular landfill area, this particular. So, this is the drainage tubes. Now, you see here This is the installation in the slopes. So, this is the HDPE liners. So, you can see here the pipes are getting joined for the leachate collection. So, and now this is the leachate collection pond finally from this landfill area. So, now this is ready for the operation. So, you can see here how the pipes are getting inject, the perforate pipes are getting into the landfill area. So, likewise, so in the pipe I think there is a low permeable layer where we are injecting the pipe, because there are a lot of fine particles are getting generated, and these fine particle can clog those openings or those perforations. To avoid those perforations, wherever I think we are injecting the pipe, perforated pipe, the outer layer will be a less permeable one. These fine particles should not be enter into that particular area. Water will only enter into the perforated pipes. So, this is the one schematic of various leachate discharge pathways. So, this is the one way the discharge is finally coming out of the leachate, and even the toe seepage also is possible. So, this is how it will look like, the collection pipes. Now, once I think these pipes is getting put it in the landfill area along with the liner, now the waste is getting disposed of onto top of this liner and leachate collection pipes. So, this is one more this leachate collection pipe. So, this is how is getting injected. So, this is also toe drainage collection. Peripherally also we can put rather than in between. This is also one view we can see. So, nearby this is a low permeable layer, this is the drainage layer, and I think refuse, and only the fine particle will not enter into this area. So, that the clogging will not be a much issue. So, the permeability K of drainage layer should be minimum of 10 to power minus 3 centimeter per second, where 10 to power minus 2 is desirable. Drainage layer gravel should be washed to remove fines and no limestone based aggregates. In the French drain used in the event of pipe failure or clogging, and additional contaminants and or leak detection system is required. So, time to time monitoring is also required if there is a leakage could be possible. So, this is a one more diagram of clean out system. So, all the pipes is connected with the manholes or where the entire leachate is getting collected. And here I think the leachate collection is separate, and even storm storm water or whatever precipitation, the surface water should collect separately, and their collection also will be separate. Their storage also is separate, because that won't have that much kind of pollutants, but the leachate should get collect separately. And now these leachate ponds or lagoons after from the landfill is getting stored. So, lined leachate pond or lagoons are commonly used at landfill sites. The double liner is used in the bottom of the liner as barrier layer with the leak detector might be employed. And aerators, now you can see these are the some aerators. So, that not only the storage, but also the treatment also could be possible to provide the initial leachate treatment to reduce the odor issue. Now, the leachate storage tank or structural basin with primary construction material includes steel, fiberglass or concrete. So, it is a fiberglass or glass lined steel leachate storage tank. I think we won't see in India such kind of collection, but in US their maximum waste goes to the landfill area. So, they have to much worried about the leachate collection also. Storage tanks are remained open to the atmosphere and often include manifold diffused of air addition. The best way of control leachate in landfill are strict storm water and runoff water, proper segregation of wet and dry waste, and aerobic landfill technology. I think this is the best way we reduce the control. So, I think as I was talking about that the wet waste is not coming and going for composting, your recyclable matters is also not coming, only the solid inert material are reaching to the landfill site. So, you need not to much worry about the landfill, your leachate production will be very low. So, I think same thing to restrict the storm and runoff water and sorting into the waste category like food waste, dry waste, and biological waste should not be enter into the landfill area. So, how to design the landfill liners? So, majorly you can see that when you talk about liner, it will start from the bottom 2 feet compacted clay layer, followed by geomembrane, geonet, geotextile, and again the soil layer, and after that we can deposit the waste onto that. So, what is the benefit of having these kind of liner? The like geotextile will help, that is the first layer after the soil. Thin synthetic layer used to minimize the intermixing of soil and sand or gravel layer. Okay. And geonet with geotextile, the drainage layer to convey leachate to the leachate collection system. So, this geonet is where only we are injecting the pipes. Geomembrane, the synthetic material which serve as an impervious barrier to the movement of leachate or landfill gas. So, the geomembrane will be in the bottom. So, that this is the complete impermeable barrier for the leakage of leachate into the ground. And finally, clay liner may crack due to the desiccation, and it needs to be ensured that clay does not dry out as it is being placed. But I think it is a very costly task, but in mostly cases what we are using, I think wherever in India the sanitary landfills are coming up, rather than, because it is a very costly units like geotextiles or geomembranes. So, what we are doing it, we put clay liner, gravels and HDPE liners. This is the common kind of liner we are using in India. So, you can see here, this is a HDPE liner which I was talking about. Is entire area is covered by HDPE liner. So, what kind of treatments of the leachate? Once you are able to collect that, we can go for reverse osmosis, but it is very costly unit for the treatment process. This could be possible by, I think this is one of the easiest method for that. We can go for flocculation, precipitation. So, if some coagulant if you add, and because as I told that BOD 5 value is because of mostly with the suspended solids. So, these suspended solids if you are able to remove by coagulation flocculation process followed by precipitation, your maybe 70 to 80% of BOD 5 will get removed out of that. And this is the one of the cheapest method of the treatment process. Now, one more technology could be like evaporation and drying. So, these techniques are separation in the clean water stream and solid phase, which includes all pollution material. So, you allow the entire leachate to get evaporate and get dry. And very common treatment process other than flocculation and precipitation is a aerated lagoons. So, lagoons also is similar kind of ponds, big ponds, and where some aerators were providing for the aerobic treatment process. As a simple leachate treatment system, retention time of leachate is long enough, so that as many bacteria can develop per unit time as the number of species that are transported out of the lagoon with the effluent, and maintenance operation cost relatively low. And this is also one technology we can use, activated sludge system. Also which contained two units, like started with aeration tank followed by secondary sedimentation tank. This is another technology we can use, like RBC or rotating biological contractor. So, there will be a rotating cylinders, you can see here rotating cylinders, and because this half is getting emerged into the leachate and half will be open to the atmosphere. So, the bacteria will grow onto the surface, and once these bacteria will insert into the leachate, it will get degrade the organic matter. So, this is different from the activated sludge process. The air supply takes place naturally, consume low amount of energy, and temperature effects are lower at RBC because they are normally covered. So, is a anaerobic biological treatment facility, like major unit is a USB technique. Okay. So, USB is a flow anaerobic sludge blanket clarifier. This is very common technology for sewage treatment, and even the activated sludge process, RBC, aerated lagoons are all sewage treatment facility. Or can use anaerobic filter, or even the hybrid bed filters also can be utilized. So, this is the upflow anaerobic filter. So, this is somewhat different from the USB unit. So, USB will be a long cylinder or long vertical vessel. Here also the vertical vessel, but this vessel will be filled with media, and the bacteria will grow onto that media, and because of that the degradation of organic matter could be possible. So, there could be integration we can do for the treatment process, like we can go for the biological treatment process first. These biological treatment with flocculation, sedimentation, or any kind of biological treatment process like activated sludge process, lagoon process, followed by reverse osmosis and evaporation. By that way, if you can combine 2-3 technologies, we will be able to treat properly this leachate. So, what are the aspects for leachate treatment plants? and finally, what has to be look upon the limiting concentration. So, whatever the concentration whether of pollutants should be as low as possible, low demand of resource, low demand of energy, low generation of residue, low environmental impact and economical efficient operation. I think this is what the criteria for the treatment process has to be there. Okay. So, the advanced leachate treatment technologies like MBBR technology we can use. This is also very popular technique for the sewage treatment or industrial wastewater treatment. So, this is a high advantage like high concentration of biomass, settling time, less sensitive to toxic substances, removal of organic substances, ammonia in a single process. So, this is also important, and this also could be combination of biological and physical process could be possible. And the benefit of these membrane bioreactors, like it lead to the growth of nitrifying bacteria. So, not only the carbonaceous pollutants will get removed out, but also the nitrogen or nitrogenous compounds also will get nitrified. So, the advantages could be less sludge production, efficient for high quality, effluent of high quality and high concentration of nitrifying bacteria could be possible. But disadvantage is only that high investment cost. So, this is the one small sketch of membrane bioreactor. So, this is what membrane. So, the current practice in landfill technology. So, now because see I did not talk much about the treatment process much because it is very costly unit, and the problem with this treatment of leachate is that you won't get the homogeneous kind of leachate every day or every time. So, even the operations of such kind of treatment plants also is not that so easy or so simple, like all these technologies are highly acceptable for the sewage treatment or any industrial treatment, because homogeneous and the particular loading, microbial consortia, many things are known for operation of such kind of technology. But now leachate, as I was talking about that, initially the leachate won't be strong or the BOD5 won't be that large, but as the time after 4 year, 5 year, the leachate production, the quantity is also very large and also the quality is also very strong. So, I do not know how these kind of biological treatment facility will work. So, like what here I am explaining now, the current practices, I think these practices is accepted in the US, because their maximum waste goes to the landfill area. So, rather than collection of this leachate and treatment is very costly process, is not that economical. So, what they come up with one technology called bioreactor technologies. This they called as a next generation landfill. So, bioreactor landfill operates to rapidly transform and degrade organic matter. The increase in waste degradation and stabilization through liquid addition and air or enhanced microbial activity. So, there will be a two type of bioreactor. They propose that one could be aerobic. In aerobic reactor, the leachate is removed from the bottom and recirculated into a landfill in a controlled manner. So, what is the idea? So, now in the previous treatment process, the task was to collect the leachate and store for the treatment process. Now, in this case, whatever leachate is getting collected, this leachate is getting collected, is stored, and now because the idea is that in the entire waste material should get aerobically degraded, whatever the organic matter. So, because aerobic degradation you required moisture also for the growth of microorganism. So, you put it onto the again recirculate into the biomass, okay, and also you put up inject the air to maintain the aerobic condition. You know that in the aerobic condition the degradation will be very fast, could be possible. So, that the entire waste material will get degraded, and also the leachate is also getting consumed for the degradation process or for the growth of microorganism. Air injection in the waste mass using vertical and horizontal waves to enhance aerobic activity. But I think again when you are saying aerobic one, so you require the energy to inject the air into the landfill area. Then this thought came, why not you go for anaerobic one, simple anaerobic. The operation is same, leachate store and again leachate stored, and again you dispose recirculate into the biomass. Now, because already the landfill is with the final cover is a closed landfill. So, the entire mass will be under the anaerobic condition. Then the anaerobic bioreactor, moisture is added to the waste mass in the form of recirculated leachate, and biodigestion occurs in the landfill area in the absence of oxygen to produce landfill gas, and primarily that gas will be the methane gas, and also possible that because in such kind of sites or such kind of bioreactor we will be able to collect this gas and can utilize that methane gas. And there is another type is a hybrid one. So, both could be possible like aerobic, anaerobic. So, in this case what could be possible, that in the top area, mostly the top area will be in the aerobic conditions and bottom area will be in the anaerobic condition. So, because the top area can be air can be injected very easily as compared to the bottom area, is not costly also. So, is possible that the top area will degrade so fast compared to the anaerobic area. Okay. So, I think this is also one technology we can use. So, this is one landfill site in the New Jersey. So, they consider that as an is a bioreactor. At a minimum, leachate is injected into a bioreactor to stimulate the natural biodegradation process. The bioreactors often used other liquid such as storm water, wastewater or wastewater treatment plant sludge to supplement leachate. Because see in US the biological waste also is not that high. So, their biological waste goes to only 20 to 30%. So, obviously, the leachate production also will be not high, but when you talk about India, I think your leachate production itself is a very high. So, but in that is why they required other kind of liquids like storm water, wastewater treatment, even sludge also they are adding because it consists of lot of microbes also. So, that which can enhance the degradation into the bioreactor facilities. The moisture content in the single most important factor that promotes the accelerated decomposition, approximately 35 to 65% optimum moisture content should be maintained for the proper degradation process. So, see entire this bioreactor system, the major important factor is to maintain the moisture for the degradation process. So, the problem in the landfill area, what will happen that because the upper portion will be always dry because it is open to atmosphere, only the bottom portion will be in the anaerobic one, and because in the anaerobic slowly degradation could be possible. and suppose there is no rain, there is no precipitation for suppose after 3 months of rainy season, almost remaining that 6 to 7 months or 8 months there is no rain. So, how the degradation will be the fast in that particular time. So, the simple thought that leachate you collected in the 3 months in the rainy season, collect it and again you supply to the remaining 7 to 8 months to get wet the entire mass, because once it will get wet the degradation will be very fast into the waste material. The effect of bioreactor is that it produces landfill gas like methane in a anaerobic unit at an earlier stage in the landfill life at an overall much higher rate of generation than traditional landfill. So, as I was talking about in the traditional landfill or not designed properly landfill area or even the normal landfill, sanitary landfill also, methane concentration you will not get it initial 2 years, 3 years or 4 years. So, but because of bioreactor, because entire material in the anaerobic condition, so you will be able to achieve more landfill gas, so that these gas can be collected and can utilize. So, here we will finish that, but I think before finishing again one last comment onto for landfill, the waste only again I think is again I am repeating that waste which is not biodegradable, not recyclable, not utilizable anything should only come to the landfill area, so that you need not too much worry about the leachate, and wherever I think the small facility will create for landfill area, go for proper lining, proper leachate collection system. Maybe we will not be able to treat that leachate because it is a very costly system. So, at least plan for such kind of facility where this entire leachate can recirculated onto the same area. That is the best way of operation of leachate collection system and followed by treatment. Thank you.